Now then, Foggy Bob here again. Had a few people asking me for like a beginner's coil building video, so we'll start at the very basics. Yeah, you need to be aware of Ohm's law, which sounds scarier than it is. This is the diagram for Ohm's law. Basically, V is your voltage, I is your current, and R is your resistance. So your voltage is whatever's in your battery, which is, if it's freshly charged off the charger, the voltage is 4.2. It's best to use that figure because that gives you the maximum potential for error. If you end up using 4.2 there, it'll give you a slightly exaggerated end figure because your battery will run at 3.7 volts after a while, but it's safer to use it at its maximum, so it'd be 4.2 for this. Your amps is basically your current, so this is the one you need to work out. Resistance is whatever your ohms are on your resistance meter or mod. If it tells you it's 0.15 ohms, then that's the figure that you use for this. To work it out, all you need to do is divide your voltage by your resistance. Whatever number that gives you is your amp draw. So your amp draw must be within the limits of your battery that you're using. So if you end up with a reading on a single battery mod with a fully charged battery, and you work this out and it's more than the amp limit of the battery, that's dangerous. You don't want to be doing that. You can, but it's at your own risk and there's nothing you can do if it goes wrong. That's on you basically, so you need to be aware of this, just to keep yourself safe and make sure you don't end up burning your house down or anything silly like that. There's a little bit of leniency in how much a battery can take, but it's worth looking at some specialist battery videos. There's a guy on YouTube called Battery Mooch, and he used to work for the government testing electronics, and everything he says about batteries is 100% accurate. So he tells you the truth of what the batteries are like. These batteries we use for vaping, these 18650s, are not really intended for use like this. They're supposed to be in safety protected battery packs, like if you've got a wireless vacuum cleaner or something like that, you know, the dustbuster things that you plug into charge, and the wireless, they'd usually have 7 or 8 of these in a sealed battery pack with a circuit protecting it from overcharge and things like that. So these can be a lot more dangerous than like your TV remote batteries. They hold a lot of power and can be dangerous. So you need to, for your safety and for those around you, you need to be aware of this. It's not to put you off, it's just you do need to know about it. Certain batteries have different capabilities. Like these 2700s can take a lot more amperage, or can put out a lot more amperage than the 18650s. So whereas a VTC 5A like this one can put out 20 to 25 amps safely, these can do up to 30 safely. So these are quite good. There seems to be more things coming out with these in, which is good, because we like bigger batteries because they last longer and you can do more with them. Sony VTC 5A is pretty much the industry standard battery. They are safe to use. Obviously with it being Sony, it's a big company. There are clones out there, but if you're buying from places like Juice Cabin or Cabin Mods, they are genuine batteries. It's worth having them. Some of the cheaper ones you can find might be for a flashlight and have a 10 amp discharge limit. If you try to put that in a mod, you're going to be on fire pretty soon, and you don't want that. So basically it's not as scary as it looks, the Ohm's law calculation. All you do is you put 4.2 for your voltage, whatever your build tells you it's at on a resistance meter or a mod. Do that equation, divide voltage by resistance. The number it gives you is the amp draw, and that's the figure you need to be aware of. A lot of mods, the regulated mods, it's not so difficult because it'll do it for you and it'll tell you what the amp draw is when you fire it. But if you're using mechanical devices, you know, like these, I mean, this has got safety features built in, so it won't fire if it's too dangerous. like tube mechs, where it's just basically a battery with an ATI on top. There's no circuit protection in this, there's nothing, it's a battery straight to the coil. And that's where people get into problems if they're not sure what they're doing, and they think that building really low is cool, like 0.06 ohms on a dual coil on a single battery that's maybe not a good quality battery. That's when people blow the legs off and stupid things like that, which makes the rest of us look bad because we put the work in to stay safe. I'm all about trying to educate people into what they're doing, because the market used to be you could buy regulated mods, and it was quite hard to get hold of mechs. But now things like the pulse bottom feed kit and things like that, they're fully mechanical mods, but people can get hold of those for like 20 or 30 quid, and you know, if they don't know what they're doing but they like the look of it, that's when people have accidents. So you need to spend good money on your batteries and probably replace them at least once a year. I've had batteries that have probably 2 to 3 years old that still work, but you know, I'm aware that I need to be careful when I'm using those. They're still hold the charge because I tend to look after them. I don't let them get too warm. But you know, battery safety is paramount to learn, especially if you're building coils, because you know, if you don't understand what the battery can and can't do, and you build a coil that looks nice but you know it's too low, it could be dangerous. So it's worth knowing this. You only need to learn it once till you know how to divide the voltage by the resistance, and that's all you need to do. So Ohm's law for vaping is basically that: divide your voltage by your resistance, the figure that comes out of that is your amp draw. That's the boring bit done with. Let's build some coils. I'm going to build probably the most basic but well performing coil, just a simple Clapton coil. It's called a Clapton coil because the end product looks a bit like a guitar string. I'm not sure who came up with it, but well done whoever that was. So basically I'm going to use 26 gauge wire and 36 gauge wire. It's quite a typical pair of wires. They don't have to be the same materials I'm using. If you're first starting, I'd recommend you use Canthal, as that's quite easy to work with and relatively high resistance wire. Stainless steel tends to taste better, but it's a lower resistance wire, so you have to be aware of what you're doing. Nichrome's kind of in the middle ground. It tastes better than Canthal. It's not as low as stainless steel. This is the industry standard wire. Anything that you might have bought a few years ago from like Kangatech or Aspire more than likely would have been nichrome. It's safe to use in power mode. You can't use it in temperature mode. You can't use Canthal in temperature mode. You can use stainless steel in temperature mode and power mode. It's safe to use. I would not recommend using titanium. I would not recommend using nickel, as in pure nickel, often known as Ni200. Ni80, the 80 basically says it's 80% nickel, but the other 20% is chromium, which seals the any potential gases from escaping when nickel gets too hot. Chromium counteracts that and stops that happening. So nichrome is good to use. You can get Ni90, which has got a higher percentage of nickel in, but it's still got that chromium in there to stop it from becoming dangerous. So we'll make a coil. Basically, if you can see here, I've got a nail drill, which at the moment I think I bought this for £20, and this is the power control for it, where you've got a forwards and backwards mode and variable speed there. You can use a normal drill, like a hand drill, as long as it's got a forwards and backwards. It's ideal for coil building. This didn't come with a chuck on. I kind of made that fit on there myself. I've just got a hook in there on mine. If you've got a jaw clamp chuck, you just fix a wire in there and tighten it down. It's the same sort of principle. Basically all this does is spin the wire. Over here, I've gone get so you can see, is a ball bearing swivel that I bought specifically for this, but that's kind of like the fail safe. If everything else fails, that'll spin. On that I've attached some ball bearing fishing swivels. Oops. And basically there's 3 ball bearing swivels there. You need 1 definitely to be able to start doing this. The more you have in a line, the smoother it'll spin. So once you get past basic Claptons, you start trying to do things like aliens, the more free spinning this end is, the easier your experience will be. So I'll chuck this back in. I'm just using 2 small identical desk clamps to hold these. So the drill's in that end, exactly the same clamp here, over here, that this sits in. So I'll get some wire out. You need a pair of flush cutters, definitely. You can use nail clippers if you're starting and can't afford to buy loads of things. These come in most Coil Master toolkits and things like that. They're not very durable, but they'll do you a while. I think I'm on my 3rd pair of these now. You can get more professional grade tools, but these work. You can use scissors to a point, but obviously not your mum's best ones. Pliers of some sort are useful. These are toothless pliers. They're just handy to have. Not 100% required, but they're useful. And if you pull some wire out to fit your system, so you've got like a hook and a swivel, pull it out, keep hold of it, hold the spool tight and pull, then the wire will just lay straight. Straight wire is easy to work with. So I attach this to mine by making a little loop and twisting it on, and then running it down and making a loop. Get my pliers and pulling it tight, and then spinning the swivel backwards, and that locks the wire on. It works quite good. I cut off any excess that's hanging out and the entire wire. So I'll show you warts and all, because you know, you too can have fun like this. So yeah, I'll pretend this part didn't happen, but I might as well show you the exact process rather than cutting it down and editing it so it looks like, you know, everything's flawless, because you'll have these same fiddles to do. So when you attach it, don't cut through both wires, just cut the end off. Right, that's that one. It's best to get all your scrap in the bin while you're working, because if it goes in your foot, or you've got kids or pets, it's, you know, you don't want to be chasing your dog or cat around trying to get a bit of metal out of its foot. Then get your wrap wire, attach it to your car however you see fit really. I just tend to wrap it round and give it a couple of turns by hand, and then it should be attached like this and free off the spool. Then if you imagine the wire's a straight line, you want to hold about a 90-degree angle, so you've got an L shape between the core and the wrap, and then start your drill up, and as it goes that way you've got to maintain this L shape, and it'll give you a nice clean Clapton. You know, you get the hang of this to the point where you don't really need to concentrate too much on it. It is a lot easier than you might think. You can go pretty quick. It's just a case of keeping a little bit of tension between your finger and thumb on here, just so the spool doesn't fly off. And away you go. Do as much of this as you need. I'll just do one stick for now, and I'll show you how to wrap them up. making them by hand, there's a little tip that'll save you a bit of headache later. So once you get to the end of your wire, stop it. If you keep the direction of your drill the same way and let the wire come back on itself, it'll lock it on at one end, which makes things a bit easier. So just sort of like roll it across itself a couple of times, and you can cut that free and try to secure it back to the spool so it don't explode on you. Then if you cut the end you've locked first free, and then this end, tidy your rubbish up. The end that was nearest your drill, if you fold it over and make a little loop on it, if you can see that. Can you see? Yep. See that little loop there? If you do that, hold it between your finger and thumb and basically twist that, it'll lock it so the wraps that you've just put on won't just all pull off like a concertina. And if you do it at the other end as well where you've locked it, just as an extra measure of security, when you roll the wire you'll end up with a nice tight finished product. So there's a stick of Clapton. We tend to call the finished wire before it's wrapped into coils a stick. So if you hear people talking about, oh, I've done a stick of this, then that's what they're on about. So I've got about a foot of Clapton there. So if I'm going to make that into coils, I have to decide what size diameter I want. Most things I've got will quite happily take a 3mm diameter coil. So I'll use these. Come with a coil master set. These are invaluable for making coils. You can use screwdrivers and things like that if you want, but these are marked so you know what diameter they are. It makes things a bit easier. So you just select which tool you want to use, put that on. You can use, they come with a little top that you can twist for coils. I prefer to do it by eye and by hand. It's just, I've got used to it. But basically if you hold one of the loops that you've made, use that as a handle, hold that tight in between your finger and thumb there, like this. Give yourself enough so you can pinch it comfortably. Then go around like this. Try keep them, if you focus on the rod and try keep them tight at this stage, it's easier than trying to tighten them up later. Basically you don't want to be twisting the wire. With a basic Clapton like this, it doesn't really matter if you do, as long as you keep them relatively tight. You need to keep tension on them. If you have to take your hand away, use something like this to keep, like your finger there, to keep the spring from, because it is basically a spring. You don't want to let go because it'll try and unspool on you. So once you get it to where you want, however many wraps you think you'd like, you can gently let go and it'll keep a little coil there for you. And then just repeat until you've got as many coils as you need, and they're all, you need to make sure if you're using like a dual coil setup that the number of wraps is identical on both sides. I'll show you a cheat of how to check that. Now if you see, I should have shown you that, I'll do it with this one. See how this one's, where's my lens? See how this one's kind of off and like you've got a leg coming off both sides. If you pull one of the legs really gently, you can wind it round so they both end up on the same side, so you can mount it. Depends what atomizer you're trying to put it in, but that'll be the best way to do it. If you take the first wrap back out, it'll be nice and tidy. I never claimed to be a teacher. Right, if you want to check that they're the same size and you can't be bothered counting them, if you hold them together and squash them together, you can basically usually see if there's a wrap more or less. On this one I've got an extra wrap on this one, but I'm going to take one out. So pull one out like that, and then cut the legs. There you go. There's two identical coils. The flavour on basic Claptons is a lot better than just a plain round wire build, because there's more nooks and crannies for the juice to get into, and the flavour's just a lot better. You can put a fair bit of power through them as well. But that's how you make a Clapton. It's a lot long-winded, a lot more long-winded than I thought it would be. But essentially all you're doing is wrapping a thin wire around a thick wire, and that's it. The most useful tips I've given you there are probably when you've made the stick to secure the ends, because if you don't do that and you start wrapping it, the wrap wire will try separate and ping off, and you'll end up with a rather scabby looking coil. But Clapton's, they're basically the benchmark flavour coil. You can make better ones, you can make really fancy coils that don't taste anywhere near as good as a basic Clapton, but once you get the Clapton technique down, it opens up a lot of different builds you can do. So I need a vape. And then I wonder how long I can upload to YouTube, because that's 20 odd minutes. Bloody hell. So anyway, hope that was useful for you. I'll catch you in the next one.